Welcome back to the Journey to the Baja 1000, where today we're getting started on the fabrication of the steering for the J10 race truck. You're watching the Journey to the Baja 1000. First, let's go into a little bit of explanation on what we're doing and why we're doing things. Let's compare this vehicle maybe to the vehicle you have out in your garage. If you have something out there that has an independent front suspension, which this one will have, and you look underneath, what you'll find is that your engine is far forward in the engine bay, and it occupies a lot of the space where the suspension, you want to have a longer suspension. And the reason is it's safer for the passenger compartment. You have radiators up there, you might have your air conditioning, all kinds of other plumbing up in the front of the engine, which limits the size of your upper A-arms for that suspension. When you start building a truck where suspension travel is the most important part, like in a trophy truck or maybe a pre-runner, now you'll see what I do with this vehicle is I push the engine further back into the firewall. And that frees up this space that's in front of the engine. Now I can at least put another foot of length on that upper suspension arm, and that translates into more suspension travel on the front of the vehicle. And that's what we're doing here. The complications that arise when you're doing that is now the steering system that you have, whether you had a rack and pinion or you're using a steering box or something like that, that becomes complicated because now where do you put those things such that they don't interfere with that traveling suspension arm? And that's what we're going to try to do today. We're going to start working on the steering for this vehicle, and let's see if we can make it fit. So when we're talking about steering for a truck build like this, the trophy trucks and those guys, they're spending $3,000, $4,000, $5,000 just for their steering boxes. And like I said, I'm making a budget race truck here. So one thing that I found in all the builds I've ever done is I've never seen a steering box fail. They're just pretty much bulletproof. They're heavy, so I'm probably going to give up a little bit as far as weight. I do need to do some designing around making this thing work, but my plan is for $0 to take this steering box that came out of the 2010 Chevy Silverado 2500 HD, and I'm going to see if I can make it work with the suspension that I'm making. Let's go ahead and take a look at the fabrication to get this box to fit inside this J10. All right. Here on my workbench is a quick look at what the steering setup is going to look like basically. So you see that the old steering box out of the 2010 Chevy Silverado is in a bracket that looks something like what it'll look like when it's finally in the J10. It'll be mounted and connected to this steering slider, I'm calling it. This is a piece of 2-inch quarter wall square tube, which is sleeved over a 1.5-inch by 3/16 wall square tube. And basically that slides nice and smooth back and forth. The pitman arm is represented by the welding wire, which is going to be 6 inches long. It'll be connected to this 3/4 inch rod end, and then it'll go ahead and slide back and forth, forcing the slider back and forth, and then the slider will be connected to the spindles with other rod ends. All right, so this is a pretty big deal. I have the steering box in the location that I'm probably going to mount it. Maybe it'll go towards the front of the car another inch or so. That's pretty close. I just wanted to confirm before I went any further with this build that I could actually get a steering shaft all the way up to the steering wheel. And without too extreme of bends on those U-joints, I can get a steering shaft underneath there. Now what I will probably do is at this U-joint right here, I'll probably extend that shaft probably an inch or two just to give myself a little more clearance away from the exhaust manifold and also a little bit more clearance underneath that power steering pump. But all in all, I think it's good to go. I'm going to continue with this plan. Here's some simple math from an online triangle calculator. The uniballs will give me about 34 degrees of deflection in each direction. My steering arm is going to be 6 inches, and so as it turns, it'll still be 6 inches. So the distance that the rod end has got to push the steering arm to go to the full lock of the uniball is about 3.5 inches. It's actually slightly less because really what's happening is that rod is pushing this direction. So It's slightly less than 3.5, but we'll just go ahead and calculate for 3.5. Next, I'm using this dial that I have drawn on the piece of paper to make sure that I get to the full deflection of the wheel before I get to the lock of the steering box. And as you can see, the lines represented here at the extremes are 3.5 inches in either direction. So as I turn the wheel, there's a half turn, there's one full turn, and then before I get to 1.5 turns, I hit that 3.5 inches, and that will be the stop of the bearing, and where I will also put the mechanical stops on the steering, and it will go beyond that. But what it does give me, as you can see, is I will have something less, maybe 2 3/4 turn, lock to lock for the steering system, which I think is going to be pretty good. So now I'm done making that part with the wood, mocking it up. I'm ready to put this into a still plate. So I'm starting with Fusion 360. So here you go. I know where the holes are going to go. I know how high I want those holes to be above where the base of the plate mounts. What I'm doing here is up the center, I'm going to reinforce this spine with a 2-inch by 2-inch square tube. And since I'm going to drill about 1.5 inch square tube or round tube in the middle of that square tube, to get a socket through there to put that bolt in, I'm extending it a little bit higher to give that square tube a little bit more rigidity, since there's going to be a lot of forces going on in this part. And then just other themes while I'm making this part is I try to round off every single corner to eliminate any stress concentrations on the part that I'm making. So let's go ahead and take this thing, put it on the plasma table, and start cutting it out, making our first real part for the truck. So this plasma table is just so awesome. But there's definitely, like anything you buy like this, there is a learning curve. And as you can see, as I cut that first hole, I'm cutting 1/4 inch plate at 25 inches per minute. Now there's a setting inside the Fusion 360 while you're setting this up, which tells you, well, after you cut a part, how fast do you want it to jog to the next part? And I left it at 25 inches per minute, so you can see it's moving as slowly as if it was cutting to the next part. In later parts that I cut, I'll dial it up to 300 inches per minute, and now it cuts a hole and then it zips to the next part it's going to cut. It goes a lot faster. And the software is really smart too. As it's cutting, you can see that it will move around the part. So just in case the part it just cut tips up, it'll actually move such that the torch won't come in contact with that part that tipped up. Here is the template that I used originally to mock up the steering box, and here's the one I just made on the plasma table. Looks pretty good. Let's see how it fits. Well, this is the first part that I made with the plasma table, and I am totally blown away with how accurate it's making the parts with the exact dimensions that I had put in there. These bolts, I did have to radius them out a little bit with a grinder, but they basically dropped right in. Well, now I'm just notching out the top of this tube that I'm going to use on the spine there. And the tool that I'm using right now is called the Beast by JD Squared. And I'm going to put a link for it in my description. Just like everything JD Square makes, it is awesome. Just the part probably weighs about 50 pounds. I literally use it as an anvil. I will bang on this thing. You can just about hold any piece of metal in there, whether you're going to tube notch or just do any kind of cutting. This thing will hold it in there. It's a really, really cool tool. So while I'm tube notching, I use WD-40 to keep the blade cool. And I can't say it's the best thing to use. You can see that it's getting an awful lot of smoke. I do my best to divert that out the door or out a window or blow it away from, so I'm not breathing in the smoke directly. But it does get pretty bad. If you do this also, in the spirit of we're helping each other build things out there, if you wouldn't mind putting that down in the comments, what you use, and then maybe we can learn from each other. So I got to put a couple holes through this spine, and I've used every kind of drill bit, step bits and everything, and they do a great job, but just never underestimate the power of a good drill press. This is an old Craftsman. I've probably had it more than 20 years, but just the ability to put big bits through thick pieces of metal quickly, nothing beats a drill press. Well, here's the final part. I'm really pleased with the way it went together. I feel like that CNC plasma table can really take fabrication to the next level. I will try in the future to take my video skills to the next level and make sure I get better camera angles and those kinds of things so you can get a better view of what I'm doing. Well, I promise you in the future that the videos are going to start getting better as I work on camera angles and all that stuff I've never done before. I guarantee you that the content's going to get a lot better. The next episode's I'm going to finish up the steering. You can kind of get a sneak peek if you look back over here. I got the whole steering system and the front end mocked up on the weld table. I'm going to get to fabrication later on this evening. Really some cool stuff's going to start happening on these coming videos. Okay, it's a budget truck. Let's talk about the budget. So for this project, I really probably only used maybe $2 or $3 worth of steel, but I'm just going to go ahead and lump the whole mess in there so I'm not just piecemealing it throughout the project. On my rack right now, what I have is a whole rack full of 1.5 inch DOM, 2 inch by 120 wall DOM. I've got a sheet of quarter plate, a sheet of 3/16 plate, and 11 gauge plate steel. And I've got a whole bunch of other smaller parts, which I've had for other projects. I'm not going to lump that into the cost. That's just freebies for this build. So right now, the total cost of the steel is $948. That brings the total cost of the build at this point to $2,906.49. I know you're like, wow, he's never going to get to $20,000. Trust me, when we start talking about shocks, we're going to get to $20,000 real quick. Well, I want to say thanks so much to those of you who have liked and subscribed to my videos. But I keep hearing from some of my friends that they just never know when the next video comes up. Let's figure out how to fix that. While you're watching the videos, there's a couple options underneath here. You got the like button you can push if you'd want. You can hit subscribe to subscribe to my channel. Importantly, there's a little bell over here. If you click on the bell and then click the option that says all, anytime I have a new video comes out, it'll give you a notification. Likewise, just on your smartphone, you still have the like, subscribe, and the bell right there. And by doing this, you won't miss the next episode of the Journey to the Baja 1000. All right, we're here with Ryan, one of the drivers from NTD Racing, and we're getting my first haircut in about 4 months.
Fast looking haircut.
Be good, brother. Do it well. Thanks again for joining us on this episode. Please don't forget to hit the like and subscribe buttons below. We'll see you in the next episode. Take care of yourself.